T7.9. A newborn baby has extremely low birth weight, ELBW, if it weighs less than 1,000 grams. A study of the health of such children in later years examined a random sample of 219 children. Their mean weight at birth was X bar equals 810 grams. So we're using the notation X bar because we're talking about the value from a sample, or the mean from a sample. This sample mean is an unbiased estimator of the population mean weight mu in the population of all ELBW babies, which means what? Okay. All right, so an unbiased estimator means that if we took our sample, right, and we plotted its value, which was 810 grams, okay, and then we took another sample, right, of another 219 random children, right, and found the mean birth weight of that group, right, would be something different, right, and then we just keep repeating this process. Like, so every day we take another sample of 219 children, calculate the mean, write that number on a sticker, and put it on a poster, right, and in the long run, what we're going to end up with is a dot plot that looks like this. Right? So it'll be approximately normal. It's going to be centered around the true mean, which we don't know what that is, right? Because at this point we've only taken one sample, right? But in theory, if we took an infinite number of samples, or not even an infinite number of samples, if we took, say, a couple hundred samples or maybe 1,000 samples, right, and we had 1,000 dots here, right, those 1,000 dots would center around the true mean weight of all of these ELBW babies. Okay. All right, so that's what unbiased means, right? That in the long run, our estimates will center around the true value. All right, so A says, in all possible samples of size 219 from this population, the mean of the values of X bar will equal 810. No. So the mean from one sample, right, one of the estimates is 810, but the average of all the estimates will not be 810. Okay, so that's not true. B, in all possible samples of size 219 from this population, the mean of the values of X bar will equal mu. Okay, so that means if we averaged all of these values together, right, it would equal whatever this number is, right, which is true because this number is in the center. Right. So B, I'm going to circle it now, but I'll read the other choices. C, as we take larger and larger samples from this population, X bar will get closer and closer to mu. I kind of like that one too. So that is a true statement, right? As the sample size increases, the variability decreases, right? The estimates get closer to the truth. Okay, but this statement has more to do with the sample size, and the question is really focusing on what it means to be unbiased. So even though C is a true statement, it's not describing biased versus unbiased. Okay, so cross off C. D, in all possible samples of size 219 from this population, the values of X bar will have a distribution that is close to normal. Okay, well, that is a true statement, right? The central limit theorem says if the sample is sufficiently large, and our rule of thumb is 30 or more, right, then the shape will be approximately normal. Okay. Now, D is a true statement, but it's not about the concept of being unbiased. D is a question about shape more so than anything else. Okay. So we're going to cross it off, even though it's a true statement. And then choice E, I don't know where that went. I guess I just didn't copy it. Choice E, here it is. Right. The person measuring the children's weights does so without any error. Okay. Yeah, so that's referring to bias on the part of the data recorder, but not it's not the same thing as an unbiased estimator. Okay, so here's what you need to know about this problem. An unbiased estimator means that if you take multiple samples and you plot out all the estimates, that the estimates will center around their true value. Okay? Or another way to think about it is if you averaged all the values of all your estimates together, right, the average of the estimates would equal the true value.